you don't have to worry. Okay, so we are going to start with question 3. So statistic, usually, I can't give you much. You have to do your own revision, please. Okay, so question 3, what you need to do is to read the question carefully. So it's talking about the way they give the discount. So you pick a ball from the bucket. Okay, so 1 ball is labeled as 100% discount. 3 balls is labeled, so it's 1 out of 50 for the first one, the answer. So what is the probability that the customer will draw the ball label 100% discount? So you see, this is a very straightforward question. So what you need to do is, you can just say 1 out of 50. Okay, if you want to make sure the examiner know what you are talking about, you say probability of 100% ball, or get 100% ball. Okay, so part B, I believe everyone got this right, correct? Then they say, if 500 customers each draw 1 ball from the basket, so actually, when they say each draw 1 ball from the basket, that means they draw already, they put it back. Hello? It's understood, they draw already, they put it back. If not, where got enough to draw? 500 customers, correct? What is the probability that more than 10 of these customers will draw the ball label 100%? So now this is some sort like a binomial distribution, correct? Some sort like a binomial distribution. Okay, can someone tell me what is the n for this binomial distribution? So we put x is a binomial distribution. 500, this is your n, and the probability of success is getting a 100% ball, right? So what is x in this case? What is x in this case? What is x? What are the possible value for x? I know this is not part of the answer, okay? What are the possible value for x? Because in the exam, they can ask you, what are the possible value for x? Yeah, 0, 1, right up to 500, correct? So I do a bit of revision for you. So what is the probability of getting x equal to r? Do you still remember the formula? Still remember the formula? If not, you better put in NCR P to the power R. Q is 1 minus P to the power of N minus R. How to use then? What do you mean by probability of X less than or equal to R? So it means probability of X equal to 0 plus until probability of X equal to R. Okay, for these two, how am I going to use my GC to get the answer? If I want to get probability of X equal to R, I use my GC, I use binom PDF. Correct? So you put in your N, P, R. For this one, less than or equal to R. This one you use binom CDF. For CDF is strictly for less than or equal to. So if I want probability of my X greater than or equal to R, then I have to use 1 minus probability of X less than or equal to R minus 1. then only I can use binom CDF and P R minus 1. So these are the things that about binomial distribution that you have to take notes of. Are you clear, class?
Yep.
Yeah. So these are the little things that I can share with you. So to answer part B, I want the probability of X. So what is X? X is the number of customers who will draw the 100% discount ball, correct? So they say, what is the probability that more than 10? More than 10, that means strictly more than 10. So this one I have to use here 1 minus, because there's no equal. So I say probability of X less than or equal to 10. Then I key into my graphic calculator binom CDF and P R. Okay, get the answer. Okay, can someone give me your answer in your answer sheets? Okay. Ashley, do you have your answer?
0.583.
583. Am I wrong or Ashley is wrong? I got 0.4169.
I got that
I
too.
got 0.416.
I got
Yeah.
0.416.
Ashley, do you get that?
Yeah, I forgot to minus the 1.
Yeah, okay, you forgot to minus the 1. Okay, yeah, 41695, a lot more. Okay, so it's approximately 0.417. 3 significant figure. Can or not?
Mm-hmm.
Okay, so that's all I can tell you. So binomial, you look at that. Okay, so C. So what is part C? Part C is talking about the shop owner could offer an alternative incentive program in which a 12% discount is given to all customers. So when you say 12% discount, okay, so now, so it's in the long run. The moment you see the word in the long run, so you are supposed to get the expected discount. You compare the expected discount with the 12% discount. Are you clear? So to get the expected discount for X, so what we do is we build the table, probability distribution table for X. So with the X, we have the 100%, we have the 50%, 25. You can put here just percentage, okay? 25, then you have 20, then the last one is 10, correct? So the probability, this is 1 over 50. This is how many got 50%? You go back to the table there, 3. 3 out of 50. You want to put it in decimal also can. 3 out of 50. Then 5 out of 50. Then 20% is 10 out of 50. So the remaining, so you see 10, 15, 19. So left with 11, am I right? What am I talking about? 15, 19. 50 minus 19. Left with 31. Yeah. So you see, very clever. Can count things that is difficult. Simple thing cannot count. Okay. So after that, you key this into your GC. Do you know how to use your GC to get the expected outcome? Expected discount?
Yes.
Yeah, if you don't want, so the expected discount. Okay, if you don't want to use your GC, you can just use your calculator, because how to get this formula? Okay, so is sum of XPI, XIPI, correct? So you just multiply and get the answer. So the expected discount, what do you get? Wing Shen, what is your answer?
I got
You got 8 ah?
8,000.
8, how to be 8,000?
Yeah, I did it wrong.
8. Wing Shen is 100 times 1 over 50 plus, continue until the last one, 10 times 31 over 50. You got 8 ah? So what is the answer? Anyone? Yes?
17.7.
Yeah, 17.7. So now, so you got this already. So they say, which is better? So in the long run, which of these two incentive scheme will cost the shop owner more? The flat 12% discount, or go by the bulk? Go by the different percentage. The different percentage will cost the owner more, because in the long run, the expected discount is 17.7, which is more than 12%. So the first incentive will cost more. This is more than 12%. So therefore, the first incentive will cost more in the long run. Are you clear? So you have to give a reason why. So here you build this table, we give you give a reason why, then you make a conclusion. Cannot? So the moment you see the expected, you see in the long run, correct? That means I want the expected discount, expected profit, expected cost, all the thing about expected. So when you talk about binomial, you have to take notes of that. So what are the things about binomial that we have to take notes of? The other one, if you go to 2021 paper, you will see there is one part you can do by try and error. Okay? Try and error, especially when they want you to find N or P. N or P or R. So if they want you to find N, P or R, then the best way is to do by try and error. You can use formula, no doubt, but it will take you a longer time. Try and error, you just take out your calculator and sub in the value and try until you get it. Are you clear? So remember, try and error is a method, especially in binomial distribution, to get N, P or R. So put a note there. You can try 2021 April paper. The paper is 2 hours, 10 minutes. For me, because I have to look at the screen, I didn't print out the paper. I look at the screen and solve it. So it take me about 1.5 hours. When I look at the screen, I cannot work fast. Hello? Can I? So can we move to the next question? Question 5. So question 5, okay. When we talk about question 5, so you talk about proportion, correct? So first of all, when you talk about confidence interval for proportion, every confidence interval, what must we have? I mark your folio, I almost want to vomit already. Okay. Okay, we must have a point estimator. Our point estimator is one of the sample proportion. For the proportion, one of the sample proportion. Okay, then we use this point estimator based on a certain confidence level. We make a prediction of true population proportion. Either by using this formula, if it's 95%, you put 1.96 square root of p hat 1 minus p hat over n. Correct? Is my formula correct? No
Wait,
one wants
should it be minus?
Yeah lah, that's why I'm asking you, is my formula correct? So the left-hand side one should be minus. The right-hand side one should be plus. Right? That is using the formula. Is the formula important? Yes. Depend on the question. So, or you use your GC. Okay, can someone tell me use your GC, which one to use? Renat? Which one to use? GC? Renat? If until now you still don't know what to use, then you better think twice. Go to stat. Right? Then go to test. Then select one prop. One prop what?
Z and interval.
Z. One prop Z interval. All right. Then you only need to key in two numbers. One is the X. The other one is the N. Am I right? Then the other one is a confidence level. Okay. So now, are you okay? So these are the things about proportion. So you call this the margin of error. Yeah, and you call this part sampling error. So that one, you have to go and do it by yourself. Okay, so part A, explain the meaning of this confidence interval. So how we explain? We are 95% confidence that the population of junior secondary school students who always keep their cupboard locked lies between 79.7% to 87.8%. You have to tell me proportion of what? Are you clear? So you get 2 marks from that. Okay. And we know that the point estimator is always the middle. Correct? So to get the answer, what proportion of students in this sample always keep their cupboard locked? So we take the lower. We take the lower plus the upper divided by 2. So we get 0.8375. So we put that as a percentage. So you get 1 mark for that. So then they say, how many students of the 320 in this sample always keep their cupboard? So that means you are looking for X. X over 320 is 0.8375. So your X is equal to 268 students. Are you okay so far? Okay. Can we move to D?
Yeah.
We move to D. So D, the senior. So when you talk about senior, for me, when I do statistics, I definitely will write down senior. Just now is junior. So for senior, N is 120. The number of students who keep their locker locked, you have to read the question carefully. They say 120 senior students and find that 64 of these students always don't keep. So our X is keep their cupboard lock. Correct? So don't keep. So you keep 120, take away 64. So you have to read carefully when you talk about statistics. 56, they play with the word. So the first part, you are supposed to find the 95% confidence interval. 95% confidence interval. Okay. Can I have someone give me the answer for your confidence interval? Hakim, do you have your confidence interval for this case? If not, you can quickly use your GC and get the answer. Hakim, you have your GC with you? You see, you have your GC with you? So can't you just straight away do it? I told you already how to use your GC. Go to stack, test, one project interval. Mikia, may I know what does your GC tell you? You see, you don't need me to call you, then only you work on it. How to? Three, 7, 7, 4. Yes. And 0.55593. So you have to write down, we are 95% confidence that the senior, the proportion of senior who always keep their cupboard locked lies between, or you can say as high as or as low as, yeah, up to you. So you must put in percentage. To 55.6%. Are you okay? So now, the next part. Can the government conclude that senior secondary students are less likely than junior secondary students to always keep their cupboard locked? Explain your answer. So how to explain the answer for this one? I can explain by illustrating the confidence interval. So the first confidence interval for junior it starts from 79% to 83%. So this is for junior. Okay, for senior, 37.7 and 55.6. This is a senior. Correct? So now, can the government conclude that senior secondary students are less likely than? So the answer is can, because we talk about the highest. The highest possible proportion for senior is only 55.6%, which is less than the lowest for the junior. So you compare between these two. So that means you are telling the examiner or the one who read this, they never overlap. So if they never overlap, that means there is no chance that they are the same. Are you clear? So the part 2 answer will be can, because the lowest possible for senior, the highest possible for senior is 55.6%, which is less than the lowest of the junior, which is 79.7%. So you say can, you get 1 mark. You explain correctly, compare between the highest for the senior and the lowest for the junior, that the lowest of the junior is still higher than the highest of the senior. Are you clear? Then you get 2 marks there. So that is how you make a comparison for confidence interval. So when I read your folio, right, I tell you, some of you compare until I also don't know which is right, which is wrong. So statistic is something that you have to be very clear how to compare. Okay? So can I move to the next one? Number 8?
Yes, miss.
Okay. So I go to question 8. So if you try to do 2021 paper, correct? Or you can even try the previous past year paper, but please take note, previous past year paper, later I will let you know which are the one included, which are the one not. Okay, so question 8. Okay. So which of the above graph represent X bar 24? Why? A, B, C. So if you compare between the 3, okay, according to central limit theorem, yeah, so which one will you choose? So the answer is B, correct? Because B is normally distributed with a smaller spread, correct? B is normally distributed with a smaller spread. So these 3 graphs illustrate an important result in statistical theory. What is the name of the theory? Everyone should know. That is central limit theorem. Okay, now, part 3. Probability of X bar 6 is greater than 375 is equal to this. If a normal distribution is used to approximate the distribution of X bar 6, is this number too large, too small, or about the right compared with the actual value? Explain your answer referring to part A1 as
Wait, Miss, A1 is B.
A1 is B.
I thought sample size of 24 is not sufficient.
So it's skew left or skew right?
Oh.
It's not sufficient. It's not sufficiently large.
So would it be
So
like
so which
C?
one will you choose? So which one will you choose?
Right, I chose C.
Why you choose C?
Because I wrote because insufficient sample size and it has a larger standard deviation compared to A. I guess because it's not normally distributed also.
Yeah. So if I give you A, B, and C lah, because that is 24. Then if you look at part 3, is 6. So isn't it 24 is way above 6? So
Yeah.
the better choice will be graph B instead of graph A or C.
All right.
Yeah.
Okay.
So that is because of the part 3. Okay. So that's why I say it refer to part B1. Okay. Now for this one, is too small or too big? So can someone give me the answer for part 3? So part 3 for X bar 6, definitely the graph is, okay, it's not, we assume it's normally distributed, then only we can count the probability, correct? So it's skewed left, right? It's skewed left. So if you assume it is normally distributed, correct? So according to that one, where the mean is somewhere here. So you have to be go like that. Am I right? The graph. Am I right? So this is, you assume it is normally distributed. Hello?
Yeah.
So now I want it to be less than what? More than 375. So 375 is here. So now this area is 0.999 something. Okay, correct or not? So if you look, the black area here, the one that is less than 375 because it's skewed left. So this area is much bigger. So that means this 0.999 is too large. Do you get me? So you have to see whether it's skewed left or skewed right. If it's skewed left, you want it to be greater than, that means your approximation is too large. Because there are a lot to the left. Are you clear? I mean, this is too large. Because the graph is skewed left.
So the 2 marks is from saying that it is skewed to the left and
because it's
saying
skewed
too
to the
large.
left, there are a lot at the left hand side.
Okay.
Do you see? But if the graph is skewed right, correct? If the graph is skewed right, if you talk about, okay, for example, my 375 is here. Depend. That's why I said depend on the original. So you assume it is normally distributed, correct? So that means you will get too small. Yeah, it will be too small because there are some more right here you didn't include. So you have to depend on the sign here and also the skewness. Are you okay? Yeah. So this one, 2020 November paper didn't come out. 2021 also, April paper don't have. But if you look at some other past year, they are. Okay. So they can ask you about all that. So I don't know what question they are going to ask you. So that's why when you do past year paper, you see something that is like that, you better get it right. These are for those who want to get a good grade in that. Okay. So can we go to part B? Yeah. A farmer owns a field of wheat. The field is divided into 80 portions of equal area. The farmer applies fertilizer and so on. Find the 95% confidence interval. Yeah, everyone should be able to do that. Am I right? Okay. So what is the confidence interval that you get? The mean? How many liter? So this one you use, which one to use? This one you are talking about, you use a sample proportion, a sample mean, as a point estimator. Then from there, you find the confidence interval through proportion using this formula, correct? This is 95%. If I change the percentage, then the confidence level, then it will change. Right? If you don't have the population standard deviation, you use the sample, then you use Z interval. Okay, I want to let you all know for this Z interval, correct? When I mark your S86, correct? All of you, okay, many of you get it wrong. Do you know why you get it wrong? When you press your Z interval, when you press your Z interval, can you place everyone? Okay, you put stat. Yeah. So you have standard deviation. Please, please, please. If the question asks you to count the standard deviation of the sample mean distribution, this is the standard deviation of the population. You're going to check your S86. Many of you, when you come to this confidence interval, you get it wrong. So for this case, the standard deviation that I key in will be 0.54. Are you clear? You don't have to divide by square root of n. You go and check your S86. Many of you, I marked already. Okay, so please take note of that. So you get here is 17.618 and here is 17.38. So you have to write down, because I give you 2 marks. You have to interpret your answer by saying that we are 95% confidence that the mean bushels of wheat harvested per portion of land can be as low as 17.4 liter and as high as 17.6 liter is a must. Are you clear? So that will be your part 1, you get 2 marks. Then your part 2. For part 2, I only give you 1 mark then you don't have to interpret. So for part 2, so for part 1, you have to say, we are da 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 da. Okay, that is part 1. For part 2, you can just write down the answer, which is 18.338 and 18.062. All right. Then part 3. Okay, part 3, that is to justify a claim. What is the claim? By using the answer in B1 and B2, comment on the manufacturer claim. What is the manufacturer claim? A new fertilizer of wheat production was introduced. The manufacturer claimed that the newest fertilizer will increase the average yield of the wheat by at least 2%. So when you say increase by at least 2%, so you have to compare between the highest possible of these highest possible mean with the lowest possible mean here. You cannot compare between the highest and the highest. You have to compare between the highest and the lowest. So you take 18.062, take away 17.618. You divide by the original times 100%. So because this will be the smallest gap. So you get 2.52%. So that means we have sufficient evidence, we have insufficient evidence to reject the claim because this is more than 2%. So the rest, when you take, it will be more than 2% because the lowest possible percentage must compare between the highest of the previous with the lowest of the new. So this is another skill. You better take notes of that. Not many of y'all, when you do your folio, you do this kind of claim. Only a few of you. Your claim are very straightforward. Okay, student? So please go through all the past year paper, especially statistics. Every year they can come up with a lot of funny things. I myself have to read through it a few times also when I solve the problem. But 2021 April paper statistics considered as easy compared to all the other year. Okay, class, any further question? Okay, everyone, you have to sit for the final paper. Even you are outstation, even you are overseas Singapore, Amali and Uma, you know where to go. Hello.
Yeah, yes, miss.
You all know, correct? Miss Pua have given you all the center.
Yes, she has.
Yeah, Ramisa.
Yes, miss. I got it too.
You got it too. So you have to prepare.
Yes, miss.
Please bear in mind. Okay, now I just want to let you know how your final can affect your result. Like for example, I got 1 year. I got a student who get A+ for 70%. But 30% correct, he got B+. Straight away the result drop. Do you know why? Okay, you see, when we say A+, this is just a rough count. Okay, A minus, B plus is 12. So how we count? 15 times 0.7 plus 12 times 0.3. So what do you get? This is just a rough count, but it can be quite accurate. Can be quite accurate. I tried it before. It is 15 times 0.7 plus 12 times 0.3. So you got 14.1. That's why A. You see or not? So don't play a fool, huh? Like those of you, if you just manage to pass, okay, I can tell you the lowest you can go for your 30%. Okay, if you get a D for your 30%, huh? Okay, I show it to you. B is 11, B minus is 10, C plus is 9, C is 8, C minus is 7, C, D plus is 6, D is 5. Okay, so I have 7 times 0.7 plus 5 times 0.3. Okay, you see, you can fail, I tell you. 7 times 0.7 plus 5 times 0.3, 6.4. 6.4 is D plus. Unless you get 6.5, then you go up to C minus. So those who have your internal as C minus, you better make sure your 30% minimum you must get D plus. You fail one subject, doesn't matter. Okay, says, I think you have get the briefing from that one. I'm just telling you the worst scenario. So you make sure you must get a D plus. So you make sure you go and learn up the basic and learn how to use a calculator. If those very difficult questions you really cannot do, just forget about it. Make sure all the easy question, the basic question you can do. Are you clear? Make sure the minimum you can do. Like those very difficult one, like for example, question A part 3, it's okay, it's fine. But at least how to find the confidence interval, write down the confidence interval properly, you can pass the paper. So you have to know, you have to strategize. You don't want to say, oh, every question also I must know it. No. So far, I'm telling you for final, correct? I hardly can see any student who can do better in final compared to their normal SAT. The percentage is maybe only 1 or 2% only. Those who are last minute worker. I can tell you frankly, if chapter by chapter also you cannot do it properly, how about the whole thing lumped together? So what you need to do is, you want to pass the 30%, you make sure you know the basic. How to use the calculator, how to write down the confidence interval, how to use the calculator to count the confidence interval, how to use the calculator to count the expected outcome. I tell you, if you are C minus, okay, by next week, by end of next week, I should be able to give you your final result. Your SAT result is done. You should know your SAT result also. Is your folio that I need to do some more changes. I try my best to make sure everyone pass, but there are certain cases I really cannot. I look through your folio. I try to help I cannot because you don't write. It's not that I don't want to help. I want, but I cannot. Are you okay? Okay, so from next week onward, we are going to discuss all the past year paper and any question from your textbook. And I advise you, please go through your textbook pages to pages, cover to cover. Okay, read through in detail, please. You have exactly 1 month. Your maths is the first paper, correct? When
Yes.
is your next paper?
1st of November.
Yeah, 1st of November, exactly 1 month from now. Yeah. So that is the thing, please. Yep. Student, any question? No, Okay. So you go through your try exam paper and let me know your mark. Yep, I trust you. Okay.
Thank you, Miss.
Yeah. Can.
Thank you, Miss.
Yep.
Thank you, Miss.
Yep.